All right, so we're back. I am again going to try this where I actually share the PowerPoint demonstration with you guys for volume. So here we go. I'm going to bring up the PowerPoint. I'm going to share the screen with you. Okay, I'm going to start my PowerPoint again at the beginning. Okay, so now you guys hopefully can actually see the PowerPoint. We're going to do the volume of a pyramid, a cone, and a sphere. And we're going to start with a formula for the volume of a sphere. The volume of a sphere is 4/3 pi r cubed. And we're going to start with problem number 10a, where we find the volume of a sphere with a radius of 6 units. The formula for the volume, again, is 4/3 pi r cubed. We're going to plug in 6 units. And so we have 4/3 pi times 216 cubic units. This gives me 288 pi cubic units. And I'll use the pi button on my calculator to get 905 cubic units. And then we're going to look at problem number 10b. We're going to find the volume of a sphere where the diameter is 24 units. If the diameter is 24 units, then the radius is going to be 12 units. And then we plug in the 12 units for r. So we have 4/3 pi times 12 units cubed, which gives me 4/3 pi times 1,728 cubic units, or 2,304 pi cubic units. And this is 7,238 cubic units. Next, we're going to find the volume of a pyramid. So remember that the volume of a prism is the area of the base times the height. On the last worksheet, you should have found that the volume of a pyramid is 1/3 times the area of the base times the height. This will also work for a cone. We're going to start with section 13.4, problem set A, problem number 6, part A. We need to find the volume of a pyramid with a square base that's 10 units on each side, and it has a slant height of 13 units. The slant height is the distance down the side of a pyramid or cone. This is like skiing down the side of a mountain. It's not the height of the pyramid. That's the distance straight down from the apex to the base. So consider this right triangle here. The hypotenuse is 13, that's the slant height, and because each side of the square is 10 units, halfway is 5 units. So we need to figure out the missing side. And we'll use the Pythagorean theorem. We'll do 5 squared plus b squared equals 13 squared, and we find that the other side is 12. So the height of this pyramid will be 12 units. And then we use the formula 1/3 times the area of the base times the height. So 1/3 times 10 units times 10 units times 12 units. This gives me 1/3 times 100 square units times 12 units. And so we have 1/3 times 1,200 cubic units, or 400 cubic units. Next, we'll look at part B of this problem. In part B, we're going to find the volume of a square pyramid where the base is 14 units on each side and the slant height is 25 units. And we're going to find the height of the pyramid by using the Pythagorean theorem. We know the slant height is 25 units, so the hypotenuse of my triangle is 25 units. And because the base is 14 by 14, we use half of that, and that gives me one leg of my right triangle as 7 units. And so using the Pythagorean theorem, we find that the missing side is 24 units. And so then the volume of my pyramid, we'll use the formula 1/3 times the area of the base times the height, times 14 units times 14 units times 24 units. The area of the base comes out to be 196 square units. And so we do 1/3 times 4,704 cubic units, and that gives me 1,568 cubic units. Next, we'll look at part B of problem number 8 to find the volume of a cone. To find the volume of a cone, we'll use the formula that the volume is 1/3 times the area of the base times the height. And in this problem, the height is 2 units and the radius of the base is 1.5 units. To find the area of the base, we'll use the formula pi r squared, and the radius is 1.5 units. So we have pi times 1.5 units squared. That gives me 2.25 pi square units. And then the volume of the cone is 1/3 times the area of the base times the height, which is 1/3 times 2.25 pi square units times 2 units. This gives me 1.5 pi cubic units. And I use the pi button on my calculator to get 4.71 cubic units. Next, we'll look at part A of this problem. In this problem, we need to find the volume of a cone with a height of 5 units and a slant height of 13 units. And we need to figure out the radius of the base. We'll use the Pythagorean theorem to do that. And we'll find that the radius of the base is 12 units. Next, we'll find the area of the base using the formula that the area is pi r squared. We know the radius is 12 units, so the area of the base ends up being 144 pi square units. And then next, we want to find the volume of the cone. It's 1/3 times the area of the base times the height, 1/3 times 144 pi square units times 25 units. And that gives me 240 pi cubic units. And then I use the pi button on my calculator to find out that that was approximately 753.98 cubic units. That's the end of my PowerPoint presentation. So I'm going to come back. Oh, wow. All right. So I don't want to share that anymore. Oh, Sean and Patricia, you came back. Awesome. I am so sorry that last time I didn't share the PowerPoint. Were you able to see the PowerPoint this time? I'm going to go ahead and stop the recording now. The next one that I do, I will look at some of the more difficult problems from this section in the textbook. And if anybody has any questions about any of the problems that I looked at today, you are, oh good, Patricia, thank you so much. You are welcome to send me an email if you'd like. If you don't know how I found my right triangles or something to find slant height or radius. But I will go ahead and stop the recording right now.